Okay, so determine the resistances if the battery supplies 3 watts of power to the circuit. And so we note then that this here is VT. And so if that circuit supplies 3 watts of power, that battery or that source supplies 3 watts of power to the circuit, remember that is PT. Okay, so you can sketch a PVIR chart for this one if you wish. And if we're bringing in the power, power is equal to I times V. And of course, we know that we can make that I squared R or V squared over R. And if we think about Ohm's law then as well, with these two equations or combinations thereof, we can, with two pieces of information about any resistor or the circuit, find the other two pieces of information about any resistor or circuit as long as we apply our formulas correctly. And so let's think about the idea that R2 we have 25 milliamps, R1 we don't really have any information about that, because remember the 24 volts does not appear across R1 or R2 because R3 is in series and that drops a piece of the voltage. So the remaining is dropped across R1 and R2. R3, we have the power value of that, but we don't have any other information. And so the only thing that we got two pieces of information about is the circuit. And so we can apply Ohm's law, I suppose, after we calculate the current, but RT is not really that helpful. So what we want to do then is start off with this equation and say that the total current for that circuit, which is also equal to I3, because I3 is in series with the source, even though it's on the bottom down there, from the power equation then will be equal to PT divided by VT. And, you know, pretty much that's the only place to start with this circuit. And so we have 3 watts divided by 24 volts. And that means then that the total current in that circuit is 0.125 amps, or if we wish 125 milliamps. Okay, so that is the current through resistor 3. And so remember now that we expect IT leaves the source at the top there, but it must go back to the source as well, and so therefore I3 is equal to IT. So now that we have two pieces of information about R3 down there, we should be able to find, well, the voltage drop across it, and of course the resistance, because what we're asked to do is find the 3 resistor values. Okay, so we'll tackle R3 first then. And we'll say that by Ohm's law, V3 is, well, actually, that's not going to help us yet, is it? Because we don't have enough information to do that. And so we'll keep Ohm's law there, because we'll, I guess, solve that for R as soon as we figure out what V3 is. And V3 is the piece of information, and that lets us do the rest of this, isn't it? And so from P equals IV, we're going to say that V3 is equal to P3 divided by I3. And for that then, we have 375 milliwatts, 0.375 watts, divided by 0.125 amps. And so only a small portion of the voltage really is dropped across R3. In any event, we work that out now, you will find that that is 3 volts equals V3. And that's a key piece of information that we need, right? So we'll go back now to our Ohm's law equation, and we'll say that once I know V3 is 3 volts, I can divide that by I3, which again was 0.125 amps. And 3 divided by 0.125 gives us 24 ohms. For R3. So that's the first piece of information, or the first answer to the question. Okay, so now let us think about KVL now around this closed loop. And if we write KVL around that loop, remember that what we're saying is VT is the applied voltage, and that is equal to the sum V1 plus V3. And from parallel circuit rules, we know that R1 and R2 are in parallel, so V1 is equal to V2. Okay, and so finding V3 up here, right, was the important calculation here, because again, it allows us to complete the rest of these calculations now. And so from KVL then, we can say that V1 is equal to VT subtract V3, and we have then 24 volts subtract 3 volts, and so V1 is equal to 21 volts. So most of the voltage is over there across those two resistors. So we go back to our original circuit now. This voltage here is 21 volts. And so that is the voltage across R1 and the voltage across R2. And so pretty much now we can carry on now and find the other two resistors. So right now, because this is true, it's R2 we have two pieces of information about. So let's tackle R2. And so for R2, we have the current and we have the voltage, right? So V2, 21 volts. I2 on the diagram, 25 milliamps. And so R2 now, by Ohm's law then, V2 divided by I2, 21 volts divided by 0.025 for the current, 0.025 amps, and that gives us R2 at 840 ohms. Okay, so one more to do, and that is R1. Okay, so for R1, so far, got one piece of information, but we'll play Kirchhoff's current law at this junction here, and so we'll say then that if I do that, Kirchhoff's current law there tells me that the current that enters is IT, and that is equal to the sum of the two currents that leave that junction, namely I1 plus I2. And so it's I1 we're trying to find right now, and it is equal to IT subtract I2, and we have 140 and 25 milliamps that we calculated for IT, and 25 milliamps for I2. So I1 then at 100 milliamps. And of course, we can write that as a decimal, 0.1 amps, because that's what we want to use in our calculation. And so next then, for R1, by Ohm's law, R1 is equal to V1 divided by I1. Remember, V1 was 21 volts, and I1 now 0.1 amps, and that means that R1 has a value of 210 ohms. Now, so that finishes what we've been asked to find, the three resistor values, right? R1 at 210, R2 at 840, and R3 at 24. Now, you know, if you got a few minutes after you does that, those calculations, what you should do is apply Ohm's law to the circuit and say that RT is equal to VT divided by IT, and you got those two numbers. And if you do that, you have 24 volts divided by 0.125 milliamps, and you come up with, I believe, 192 ohms. Now, in order to check this, do product over sum for R1 and R2, which is 210 multiplied by 840 over 210 plus 840, and you come up with 168 ohms. And the total resistance of this circuit is the 168 plus the 24, and that'll verify that you can calculate RT in two ways and come up with 192 ohms both times. And so therefore, you know, that tells you that you've got this done correctly and that you haven't made a mistake. And so